Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see how to build a very simple application in Streamlit using Ell together with some various concepts, right? So let's see what we're building. So we already know that in most LLM applications, we have this particular flow. So we have a user that types in some prompt, right, into some LLM application, and then we get a response. So in most applications like Perplexity or U or Pink, all of them follows this particular approach. But behind the scene, this is a firstly a simple one. Behind the scene, we can make it better, right? To give it a better response. That is where we go with RAG, right? So in a RAG system or RAG application, we have a user that sends in a prompt, and then when he sends in a prompt, it goes through an embedding layer, and the embedding layer is exposed to either some docs, some database, some ontology, or some domain knowledge somewhere. Then we get some tests that are similar, right? Via cosine similarity or Euclidean similarity. Then we get the retrieved data. Together, we combine it with the initial prompt. Then we make, by doing so, we make the initial query context aware, right? Very, very robust. And then we send this particular context aware detail to an LLM. And then the LLM returns the response, right? So that is the simple, more robust application. So let's see how it works here. So if I come back here to my application, I can select, as you can see from here, we have some tests. So I can go back here. Let's refresh this and start over again. Right, so if I come back here, I can select the model. So I can choose LLM model, and then I can specify the personality trait. So in this case, we are trying to argument it with role-based thinking. So I can say this is an introvert person, and then this is also a thinking person, right? You can add more to it, and I can augment it with some data. So let's pass in this data here, as we did earlier on, and this is the data there. Now I can access a question. So what are the applications of AI infrastructure, right? Something like that. So what are the applications of, what is the usefulness? Yeah. So if I send it there, so this test is sent, and you can see that it's I sent what are the usefulness of AI infrastructure. Then it brings the usefulness of AI infrastructure lies in ability to enable effective and efficient workflows, right? So it gave us some stuff and it gave us some documents. So this is based on a document I placed here. It gives us a form of reference, right, of based on vector store or embedding based on the relevance. So that's where artificial intelligence, so this is something coming from the test that we submitted. And then we also have a debugger. So if I go back to the debugger, we can see the chain of thought prompting, which is very useful to help you explain why our model gave us this particular prediction, right? So we have the first step. So step one, this is, I start by analyzing the provided context, which comprises two documents with relevant information about AI. So that is what the LLM is doing first. Then it went to the second step, retrieves the information, then it generates the response, right, which is the response here, and then it's move on and provide the final answer here, right? So this is the final answer that we got here. Very cool. And that is the final answer that you are seeing here. So with this particular approach, the user only sees the final answer, but we can see from the debugger the steps it took to generate this particular answer, right? So this is a very simple approach that allows you to build more robust application in which you have a user that sends a prompt, and the prompt is going to pass through an embedding layer. So an embedding layer is going to convert the text into vectors, right? Vectors of strings or of numbers, because LLMs don't understand text, they only understand numbers. And this embedding layer is based on the document you are sending. So it can be PDF, it can be CSV, or it can be a database, or it can be your ontology. So your ontology is your knowledge graph, right? Simply a study of all the knowledge or of all the structures and entities in your system and their relationship, which is very useful, the connections. And with those things, we argument your prompt via the embedding layer. We find a similar test as you could see from here, which was these similar tests here, right? So this is the document it retrieved from what we had, which we uploaded here, together with the relevance, and then we send those information together to make it more context aware to our LLM, and the LLM returns some response, right? And because we are using chain of thought prompting, we can explain from the debugger what step it took, making the LLM or my application not like a black box. And if I go back here, we also have some reference, right? So which makes it easy to explain the prediction. So we know that it took some information somewhere, but we also have some information here, right? Which is this step here. And then in case we have another tool, we can expose it to that tool in case we need it to be, and then we return some response. So let's see how to build this application from scratch. So I'll go back again to my workspace here. Apologies for all the talking. So this is coming from Ell, and then I'm going to open my location. So let's get out of here, then script activate, and then let's move into my LLM toolchain. I'm going to create another application. So let's call it as let's create a directory. Now I'll call it as my RAG app, right? So cd into my RAG app, then let's create a file called app.py. So this is going to be our simple application, and I'll open this one with VS Code. We're going to be building our simple application from scratch. So apologies for this long video, and let me stop the old one that is running. So this is the old one that we're running, so let me stop it. We'll just stop this old application here, right? And then we will run everything from here. So let's edit from here, and then we have it here, right? Perfect. So what I'll be doing is that first, in case you don't have Streamlit, so import Streamlit. You also need to import Ell-ai, right? And then we will also import any other tool we need. So I import pandas in case you want to work with pandas. I will also import, these are the three mains after Streamlit, AI, pandas, and then Scikit-learn. We are not using any external vector store. You can use it, right? You can use any of them, but we are just using these two. So these are the tools we are using for application. And of course you need NumPy, right? Okay, so let's start with it. So I'll open my application, which is the one here, open. And then I will do some preparation so that we can follow through with what you are doing, right? So in case you have any question or contribution, you can put it inside the comment section below. And apologies for how long this video is going to be, because we are trying to build an application based on some concepts, right? Okay, so let's start with it. So first I'm going to import Streamlit, right? As we already know, as st. And then I will just, after importing Streamlit, what I want to do is that I will just create a simple user interface for application, right? So let's create my import pandas as PD, right? And then these are the stuff that will be imported, right? And let me import time, and then let's import L, right? And then I'm going to import Scikit-learn to help me with my feature store, so feature extraction. Import, let's go with .test, import test tfidf, right? You can use any vector store, but this is what I'll be using. And then I will use from sklearn we need to import metrics cosine similarity. I want to import cosine similarity, right? So this two will be used to help build our embedding layer, right? And then this will be for our LLM. So let's start with the basic workflow for application. So I'm just going to go back again, and then as we already know, the new format of Streamlit makes it very easy to build simple application. All you need to do is to define your apps. So let's define it. So this is going to be my def. Now I call this about page, and then we can just st.subheader about, and then I'll do another one. So def.st.say at LLM page. I'll call it as this, and then st.subheader. So let's go to ax LLM RAG app, right? Something like yeah. So this is LLM RAG application. Perfect. So we have our 2 pages, and then we will simply create our navigation. So my about page is going to be my st.page. Then I'll pass in the about page. Then you can also pass in, let's say, a title for it, which will be about. And then we can pass in, let's say, an icon. So let's give it a simple icon. So the icon I want to give is material info, right? So this is the first one. Then I'll repeat the same for this, for my ask. So it got as LLM page. So let's go to SLLM, and then I'll pass my ask LLM page here. And then this I'll call it as LLM, right? And then let's change this one to chat, right? So we have gotten something very simple. And how do we connect them? So we go with my PG for the navigation, so st.navigation. Then I'll pass in as a dictionary my home page, which will take in my ask LM. And then the next one is going to be my about page, which will take in my about page, right? About. And then that is all, right? So simple. We have built our simple workflow. So this is the navigation. So all this is my navigation. And then I will just simply close it with my pg.run. Let's save it here. Perfect. So let's see what we have built so far. So I'll go back again to my workspace here. Then I'll run it with Streamlit run app.py, and this is going to open my browser, right? Which is this one here. So let's copy. Yeah, you see I like Marvel moves. And then I will paste it in the right place. So let's paste it here, right? So let's stop this, and then this is the old one. So I'll close this one. This is what we are trying to build, right? We are trying to build this workflow first, and then we'll see how to build this workflow. We have my LLM, right? You can see that we have this session here, the about, nothing, and then a RAG app, right? Okay. Now let's continue. So I hope it's big enough for everybody to see. I have gotten our simple structure. Now, how do you build a first workflow? To build a first workflow, what we can do is that we can go back to our LLM app, right? So first, I'll just come back here. And then what I want to do is that I want to have an interface for the chat, right? I just want to build a first layer first. So to do that, all I will do is go with my, let's call that query, which is going to be st.chat app. Then this will take in my as LLM, something like that here, right? So this is my simple query. Then I'm going to say that if there is a query, then we want to also use sessions to store whatever is happening, right? So how do we do that? So we can simply initialize our settings. Go with st.session state. Then let's go with messages.append. We will create it later. Then I'll pass it here. So we have the role. We have the role is going to be user as always. Then we have the content. The reason I'm doing this is in case you want to use this, right? Then I'll go with my query for any different application. So we have it here. And then the next thing is that I'll say with st.chat message, I'll pass in the user. So as you can see, there is some literal, so the user assistant AI human. Let's go with user. Then I can now return the stuff. So write my query. Right, perfect. So this is something very basic. So if I run it, we have my interface here, right? So this is, I can just type in something. If I type in something, so hello, it works. So that, okay, sessions has no attribute messages, right? Did you forget to initialize it? So first, the reason we have any issue is that we need to ensure that we initialize these messages, right? Because we are using session state, we have to first of all initialize it, otherwise it's not going to work. So how do we do that? So Streamlit make it very easy to initialize all of these things. So the first thing is that I'll just go back again to here. Before we run our application, let's initialize my session state. And how do we do that? I can say that if message not in my st.session state, then I want to create it, right? st.session state dot message, and I'll pass it here, right? So this initializes it. So now if I type in, it works. So now it works here, right? Perfect. So that is the first workflow, right? Now we want to also, based on this our workflow, we want to add an LLM Gen AI engine to it so that we can send a test and then get a response. Let's see how to do that without the vector store. So first you'll be using Ell to help us with that, and then as we already learned earlier on, in case you have not checked out Ell, you can check it out. As we already learned earlier, we will use Ell to help us with that, right? So let's go with something like this. So first I'll simply go with my def, then I'll call it as my RAG system, RAG. I can just call it as any name. I'll pass in my query, which is a string, and I'll pass in my context, right? So now let's not pass in any context yet, and I can just return some stuff. So let's return f. So this is going to be something like, I say, you are an AI assistant with the following personality traits, right? So I want to have the personality traits here. And then since I want to add it, I'll just go with my personality traits. So this will be a list of string, right? Of strings. And then let's give it the first one, which is going to be thinking, right? So yeah, and then because I'm using this, I need to import from type instance, and then you have it here, right? So something like that. So giving the, yeah, so I'll just say answer questions about this, and here I'll pass in my query, right? Perfect. And then this is going to return the response. So how do I decorate this one? So I'll use Ell to help us decorate it. So Ell comes with its own option, so I'll just go with Ell. That's simple. Then I'll specify the model I want to use and the client. So I'm using Llama 3 to help us with that. And then this option here, so this I'll just define right. Perfect. But this will not see it, right? I need an env to allow it to see it. So I'll just have to come back here and then import. So wait from .env import load env, right? And I'll need to load env. So this was going to load my env, but I do not have an env. So I need to go to grok and get my env. So I'll just copy it here. So let's go back here. See that it's giving us an error. I'll just copy my env. So here, I don't want you to see it. So I have it here. I can just copy this .env to my RAG. Yeah. So now you can see that I have it here, right? And I automatically load it. So now if I load it, I can have it working perfectly well. It's secret. So let's see how to use it. So we have gotten our query. Now we need to pass in our query, right, to the RAG function that we have defined so that it will be able to give us some response. So how do we simply do something like that? So what I'll do is that I'll just go back again here, and I'll say that with st.thinking or spinner, I'll say thinking, right, the dot, then I will now process whatever thing I want, right? So I'm just going to go straight away with the response. So I call that my result. So this is going to be the LLM model, right? So results is going to be my RAG that I defined above. Then I'll pass in my query. Then I'll pass in my personality trait. So personality trait, which I have not defined. So how do I define it? So to define the personality trait, I can come back to, let's do it here. What I want to do is I'll do it here, and then I'll just have a list. So let's go just selected traits, which is going to be st.sidebar.multi-select. I want to have a list of, so personality. I want to have a list of personality traits, and I'll pass it there so that the user can just select from any of them, right? A list of them. So I have a collection of them. I have a dictionary. So let me expand it. Let's go back here. I have a dictionary of personality traits, and then I'll pass this dictionary here, right? I want to pass it inside this, so I can simply do list. Oh yeah, simply personality traits dot keys, right, to get all the keys. Just passing it here, right, so that we have it here. So whatever is selected is what we get here, right? And then we are going to pass that selected trait inside this particular place. So let's make it like, yeah. Yeah. And now we have gotten our response. So once we get a response, we can store the response that you are getting, or we can simply return it straight away. So we can go with st.write. Yes, write stream, and this write stream requires a generator, an iterable, for it to work. And I already created my generator some time ago, so I just want to use it to save us time because it's just a simple function. So I'll just go back here on top of my app, and I'll just define my generator function, right? So inside my RAG, let's go. We have what is doing that we loop through the test, we split the test, we loop through them, then you roll them one at a time, right? So that's a big understanding. So now I'll pass it here, my stream test, I'll pass in my result. So let's see what you have built so far. So if I go back to the application, we have my application here. If I go back here, we have the personality trait here. I can select introverted, I can select thinking, right? And now I can just type in something. So what is a chain of thought prompting, right? So this, once I send this, it's sending this one to the LLM, right? So it's giving us an error here. So this LLM, ensure the model is registered using register model. So we need to register the model because we are using Croc. You're not using OpenAI, right? So we need to register the model. So that's why it's failing. So first, to register it, I need to go back here, and then let's initialize L, right? So we are initializing L. We want to initialize L because we are using Croc model. We are using this, the inside here we have my Croc model. That's what I'm using, so that's why it failed. So what is chain of thoughts prompting? If If I run it, now it's that it's running. So thinking, as an introverted and thinking AI assistant, is that it picked the personality and it gave us this response, right? Very cool. So this is this first type of LLM in which you have a human being sent a prompt to a Gen AI, returns a response. Perfect, right? So that's the simple one we built. Now let's make it different. Let's make it better, right? Because this is okay, but let's make it better. So how do we make this better? We will go to the next step, which is trying to add some form of data layer together with an embedding layer to our application so that we make it retrieval augmented generation app, right? Okay, so let's see how to do that. So I will want to keep track of whatever is happening in my model. So I'll just go with this option here so that we keep track of it, just to store it for myself. And then I will need to do that. We need these things. First, we need a vector store, right? So either you use a vector store like Chroma or ChromaDB or Melvis or any of these, or Pinecone, any of these. So like Pinecone, any of these vector database, or you can just use ChromaDB, or you can use Melvis vector store, or you can use Quadrant DB. Yeah, so any of these vector database you can use, right? So any of them you can use, but we don't want to use that. We want to use our own simple implementation. So let's see how to do that to build this, right? So I'll call it my vector store. So here, so we have it, my LLM here. We have my personality. What I'll do is I'll just come down here and then we'll create our vector store. So we use Scikit-learn to do that, right? So let's go to class vector store. It can be any. Then I'll just create a dictionary, or initialize a simple class. So this class is going to take in myself.vectorizer, which in this case you use the vectorizer. We will use term frequency. So and then we will use self.tfidf matrix, which is going to be my tfidf. Yeah, I already have it here, so let's copy it to save us time. Right, so we have a vector store which has my vectorizer, my tfid matrix, and then my document. Then we need to create some vectorization for it, right? So I'll just create class method, and most class method always go with by convention from something. So from document, I'll pass in my class and I'll pass in the documents, right? And then once I do that, what I want to do is that I want to get my vectorizer, and I'll use tfidf vectorizer. You can just add the parameters. As you can see from here, there are different things you can pass there, right? You can pass all the different forms of processing, text processing like tokenizer, analyzer, stop, where, remove out, all of them. But let's leave it with the default. Then I will create my tfidf matrix. So tfidf matrix, this one here. And then I'll now vectorize it. So vectorize dot fit transform, and I'll pass in my documents. The document must always be a list. Then I'll return my class because it's a class method, my vectorizer, and then my tfidf matrix together with my documents. Perfect, right? So this is something very basic that you have built. Then the next thing we need to do is now to search. So how do you work on a search? So def, because that's search, then the search will take in self because it's a class. It's not a class method, it's just a normal method. Then I'll pass in my query. Then my query is a string, right? And then I'll pass in some parameters. So let's say k. Let's paste it and explain so that it's easy. Okay, so what we are doing is that we created a method called search that takes in a query, the query you pass, and then some k sorting, right? So the number of similarities we want. And then this is not the right way of doing this. We have to make it like list. Yeah, even this we have to specify, right? The output is string and some text, but let's keep it like this for now. And then we are using NumPy. So let me import NumPy. So what we are doing is that we create our vectors. Whatever text we are sending, we vectorize it, we convert it to text. Then we pass that vectorized text to our document text, our TF-IDM matrix, and then we find the similarity between them. Then once we find the similarity based on what you have specified, so in case we want 4 or 3 or 2, right, we specify it, and then it's going to find the top k. So in case this is 4, it will be 4 for the similarities, and then we're going to return a dictionary of them, right? Perfect. So this is going to be our simple vector. So very simple, right? No need of any other external packages, just Scikit-learn. Okay, and then let's see how to use it for application. So to use it now, what we will do is that we need a place to get the data, right? So I'll come down to my application here, and then let's go with my uploaded data. So we need something to get data from what you are sending, right? Otherwise, I mean, we need a place to file. Then st.fileUploader. This one is going to take in my data. So let's say upload. And then we specify the type. The type we are getting only CSV and then TST, right? We don't want more. So if I save it and I come down here to my application, so you're no more using vector data, any of the vector databases or quadrants, you can use it, but now you see that I have it here, right? But I want to push it to this side. So Streamlit make it easy. Sidebar dot, and then it's here, right? And now I can upload the file. So once I upload the file, I want to check the type of file, right? So we're going to say if uploaded file is not none, I want to, and then since we can take CSV or TST, I want to use different ways to load the data. We can check the file type. So if uploaded dot type, right, is equal to test/CSV, right? If that is the case, then I want to call it as raw data. Then I want to load it with pandas. So let's call it as load data. Then I pass in the uploaded file, right? Then we need to create this function. So let's go up here. I'll create it here. So I'll call it as def load data. And this is going to take in the file, then return pd.read underscore CSV, then the file, right? So this is a simple function just to load it. Yeah. And then once we load the data, so now we have loaded the data, we can now specify and check. So sometimes in case there's no file, we need to also ensure that. So if raw data is not none, right? Our function does not return none, but we will work on that later. I'll just call it as my document, right? So document, then I will pick the test column. So in case our test, so let's first do this. Let's say raw data dot head, right? And then I will just return it. So st.data frame. You want to see the data first. let's see if it's working little by little. So now let's upload. And let's upload some CSV. Here, do I have a CSV? Yes, I have the CSV, which is not that big. If I upload it, now we have our data, right? So within our data, we have a test here, right? Tweet. So that's what I want to get from here. For now, we can make it better later, right? You can specify the option for the user to specify the column to pick from, right? So we can do that here. You can also add that column here, right? The column that you want the user to use. But yeah, let's keep it as tweet for now. Later on we will change it. Then what is next? What is next is that we want to convert this entire stuff into vector database to use it, right? So I'll go back, initialize one. So if this is going to be vector store, but in st.session state, st.session state dot vector store is equal to something. So we will now initialize that one to have the vector store, so we can have the vector store there. So let's set it as none for now, right? And then I'll come down to here, right? So we have gotten our data, we can see the data, but what we want to do is that we want to convert the data that we have into, we want to vectorize it, right? So we can just do this, st.vectorstore st.session state vector store vector store, right? And then I'll pass in my function. So we have the vector store function from document. Then I'll pass in my document, right? So this is going to convert the entire stuff into embeddings. Perfect. So something very basic, something very simple. Then we can also do the same. So if it is test, do this. What if it's a plain test? So let's say if the uploaded file type is equal to test, that's plain test, we now want to get the data, right? We want to get the raw data, just like the same thing. And I'm going to call just my uploaded file dot get value dot decode UTF-8. Yeah, so we have it here. Yeah, so that we get the data, and now we can just return it, right? So if there is raw data, then I can now comment. We can split it, right? Because here, even for here, I think there's a mistake here. We need to convert this one to list, right? Because most of the time, it's always supposed to take it as a list, right? So this, my raw data dot split. We need to split because it always requires a list. Split it not into tokens but into array. Then I'll do the same thing. Then I'll pass it there, right? I can, let's write it st.write the raw data. We want to see if it's working, right? Before we move on. So if I come back here, see that the first one works. And then if I go back and I change this, and let's pick some tests. So I have some tests here, the one we use for our test. And now you see that it's working, right? Perfect. So we have seen how to get the data into our application. Now, how do we apply our data to the RAG system? That is the next step I want to do. So what I want to do, that this is just for the LLM, right? I want to also have another session in which we can query between. So we have one for this. Let's go back here. Let's have one for the model only, right? Because you just want to test the application against possibility that I can just go back here, and then I'll just put it here, right? So what we want to do is that we want to have a session here, select response model. So we can have LLM or vector store, and then if it is LLM, we just use the system. If it is vector store only, we just use the vector store. So I'll just go down here. So we have gotten our query, gotten our spinning. We can now specify or tell the model that we want to either use the large language model or to use my RAG system, right? So we can say that so if the response model is equal to LLM model, then we use it. Else, we just use the vector store, right? So in that case, we just go straight away to my vector store, which I can just simply go with this option here. So with st.chat message, let's pass in AI, or we can call it as, yeah, let's keep it as AI. It's not an AI, but let's keep it like that. Let's give it assistant because the vector store is not. And then now I can return those data, right? So let's return the particular data we want to return from the vector store. So we have gotten the charts. We have gotten the vector store stuff. Let's go with this. So context is going to be my st.session_state.vector_store .search. Remember that the vector store is here, right? We have gotten it here, so this is it, right? So we want to get that search here, right? And then we want to query. So the vector store, we have query, and the query is going to be the query that we have. So let's go to my query. Perfect. And remember that the query also, this query function here had some number that we can specify, but now let's keep it like that as 2. So let me make it better. And then let's return this. So in case I want to write it, so st.write stream, then I can pass in my, this is going to come as a dictionary, right? So I can simply pass it as let's pass in straight away. Because it's a dictionary, right, we cannot stream it. So what I'll do is I'll pass it like this, my context. We'll see how to stream it straight away. Now let's go back from here. I'm using the vector store only, and then let's ask something. So now if I ask something, so let's go as what is AI, and now it's not using the large language model, it's rather using the vector store, right? So you could start what is AI. It just picked the text from here, if you can see. So what is AI? And it just picked the same stuff. You can see it's picked the most relevant stuff, and it gave us a confidence score or relevance score, similarity index of this, right? So this is not using any LLM. So this is this particular aspect of the application. We have built just this aspect. So we have a prompt sent to the embedding layer, and then it checked the document that we supplied, which was this document here, right? This document that we supplied here, and then it's converted it into vectors together with the document, and then give us a similarity index, which was this, right? So what is AI, or what was asked, it just checked it out, and this is the relevant one. Perfect. So we have done here, 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 and then here. We have not sent the data to the LLM yet, right? So even with this is a very useful application you can actually build. So most of the search engines use this format, in which you can just type in something, retrieve those things, which is good. But we want to use the LLM here to make it better. So let's improve this one that we have done so far. So I want to improve this thinking, because sometimes it may not always have the vector store. So I can just come down here and say that if the st.session state.vector store, if it is not none, right, we will now get the context, right? So we search for it, because we will use this one for both of them. I'll copy it and paste it here, and then let's put this one here, right? So it will use it will use the search query, the embeddings together for the model, if there's the model and if there's not the model, right? So both of them, that's why I put it at the top. Perfect. So that is something just to make it better. And then I will say that if there's no, because now if I go back to my application here, let's clear off this, and if I search for something, this is vector only, right? Hello, that is empty, right? It gives us empty stuff. We need to find a way that in case there's no data, it tells us there's no data, right? The reason it worked was because it has something still stored. But now if there's nothing stored, and I say hello, it's using the model. It's funny. I want to show you without the model, vector store only. It's filled. Non-type object has no attribute search. So we need to fix this error. So that is why we put it here. So that's why we are saying that if searching states exist, then we go through this, right? Else, we need to tell the user that there is no information. So now if I run and I go back, vector store, there's nothing there. I say hello, no document loaded, right? Please upload first. So this is user friendly. Okay, now let's see another stuff. So as you could see, right, we already had an issue in which it automatically picked the first model. So we can switch, I can switch this one. Let's pick the vector store first. We don't want to spend all our money for the LLM. Okay, so that is always the first one, right? Yeah, perfect. Okay, now we are done with this aspect of the workflow. We need to find a way of adding the data to the LLM. That's our next task. So I'll go back here. And we also, it is nicer, it would be nice if we can keep track of the information that is being shown at the top, right? So I would show it here, but I also want to store the results that we get from the LLMs somewhere, right? Because now we get the result, we process it, we get all of those things, but we are not showing it, right? We need to store it. So I'll pass this same stuff here. this is going to get the result. We want to pass the entire result. Perfect, right? We want a means to store it, and it would be nice if we have a chat message like this also. So I'll copy this. Let's do this. So with st.chat message, this is now going to be AI. Then I can now pass it here. But we need to stream the data, right? We need to stream the text, which we are doing here. But we cannot stream we cannot stream this. Right, so if I go back and I say hello, no document, but if I pass in some document, and let's pass in this document, the same document we are using, and I pass in AI, it just came straight, right? But we need a way of streaming it, right? We can do that later, but yeah, we will not do it now. Okay, so that is it. We are done with it. So we also need to pass in the data from this one also, just as we did here. We can also apply the same logic and then store it, right? You want to store all of them. So this is going to be not user anymore. This will be assistant. Yeah, and then this will be AI, right? So that we have different. So we have one for the user, one for the AI LLM, and then one for the assistant, right? Okay, but we want to also display this information when the user comes to the application. So how do we automatically display the information? We can come to the top of my application. Before here, I want to display it here. My chat history. So we want to display the chat history. It's going to be for message in my st.sessions state.messages. Here we can make it better. So we can do with st.chat message. I'll pass in my message. Let's get. Then I'll pass in the row, right? So we want to get the row. Then once we get the row, for message, I spelled it wrong. For message, yeah. Once we get the row, we also want to turn. So st.write the message dot get the actual content. So we are returning this and returning this, right? So that if I go back to the application, if I refresh, now you see whatever message that was sent. So if I go with hello, it works. Remember that there is no data yet, so I have to upload some data. And if I return it, so result where it is not located. So let's see where it's failing. So under line 129, we have a mistake. 129. So we have the context here. We have results, but what is result? We don't know. Right, we don't know what the result is. This is if it's RAG, we get it. If it's not RAG, this is supposed to be my context, not result. Because we are getting the context here, and now we are returning the result here, right? Something different. So if I rerun, now we have it works. Perfect, right? So we have it here, right? So this is work. This is useful, and we can keep it as for the information. So we are done with this side of the application. We have done it here. Now let's work on this aspect here. So now we want to embed the retrieve test together with the query and then send it to the Gen.ai. How do we do that? So that is quite simple to do. What we do is that we need to continue with prompt engineering, right? So I'll copy this, and then I will change this one from RAG to RAG Debugger, right? So this is the simple one, and this is the debugger. So we have the personality traits. I want to also pass in the context, which is going to be a string. So the context here is the string we are getting from the large language model, right? That's what we are passing that particular one there, and we need to change this message, right? Because we want it to be more robust and we want to add debugging to it using chain of thought prompting. We need to change this message. So I already have the message here, and then I'll just paste it, right, to save us time. Now explain. So what is it doing? So we have my RAG debugger, which takes in the test, the context, and the query, right? So, and it also takes in the personality traits. So you are an AI assistant with the following personality traits, and using retrieval augmented generation combined with chain of thought prompting, and I explain what RAG does, and then I say that given the following query and relevant context, right? So this is the query, this is the relevant context. Please provide comprehensive and accurate response, and break down your reasoning into step-by-step intermediate steps, right? So this is where the chain of thought prompting comes. So I'm telling it to break the reasoning into step-by-step, and then put the step-by-step here in this format. The reason we are putting it in this format is that we want to be able to pass it. In case you want, there's also another way. You can use the complex instead of this here. You can also do something like this. And then you can pass in, as you can see, you can pass in tools, client, callback, and stuff. And then here, instead of this, you can now pass in, let's say in case you have a response. So this response model can be pedantic. So it can be something like this. So class response model, then you inherit from base model, from pedantic, then you define whatever you want to define, right? This is structured prompting, right? And then you pass it here, but we don't want to use it. That is in case you are using the complex model and you are using GPT-4o or something, but this does not work. So I'm just going with my simple stuff, right? Simple always is okay. And then here, this is returning my string, right? Perfect. So now it takes in all of this, returns a string, and this is going to be the response, and this is the string, and this is the format I want, right? I can structure the format if I'm using a complex one, but this is not going to work if I use this particular model, right? Perfect. Now this is where all the logic comes in. So what I'm doing is that so the idea, I think the idea behind RAG is that we are just increasing the context window of what is sent to the LLM, right? So in case, that's why most of the LLMs, the modern ones, the new ones, and the feature coming ones are always trying to increase the context window, because if you have a larger context, you can place in more stuff. So with the RAG system here, we are just embedding our initial query with some relevant retrieved data so that it becomes context aware, and then we send that particular context to the LLM. So that's what we're trying to do here, right? So this is our entire content prompt. We are embedding the query here, we are embedding the context from the RAG system here, and then because we want to explain it, we are passing it here, right, in this particular format. Perfect. So let's see if it works, right? So I'll just go back again, and I'll change it from RAG to RAG Debugger, right? And now with the RAG Debugger, we have our query, we have the selected trait, and then we need to pass in our context, right? So we are passing in this context, which we retrieved from the vector store here, and then we are passing in our selected traits. Then this is going to return some results, right? So let's save it and let's check and see. So we want to try and see if it returns something useful. So let's call it as, okay, how do ML ops helps in AI infrastructure, right? So that is something. So what it's going to do is that it's combining all of them. So now, so you see that it's thinking. So this time it just went straight away without the model. So let's switch here, and then let me ask the question again. How does and now you can see that it's thinking, and you can see that just because there is a chain of thought prompting, it's giving us more information, and then you can see what it returned to us, right? All of our result here. Perfect. So this is good, very cool. We have built it, but we want to make it not just a black box, right? So how do we add a debugger to it? So in order not to make it a black box, and as you can see, the result we got is exactly as it was structured, right? So we have step 1, we have step 2, we have step 3, right? And then we have final response. It's called as response, but what I need is, so there's response, there's conclusion. It's funny. Yeah. So what we want to do is that we go back again to here, right? And then we will write a simple function to pass them. So let's bring the function that is going to be used to pass it out. This is a simple function. Apologies for this. I don't want to go through typing the whole function out. So let's go back here and pass in the function. So what does the function do? So we are just passing the chain of thought prompt because we have steps. The reason we are using this is because our model does not support structured prompting yet, right? Because of L, but we can automatically pass it straight away, and then we don't need to pass it again. So what we are doing is that we just take all the terms that start with step. So we are splitting by step. We pick the first one. We don't want the first one. And then we, for every step test in steps test, we now get them and append it to this dictionary. Simple, right? And then the final test is going to be our response. The final answer, which is going to be the last one. I'm going to return it, right? Okay, so let's now go back to here. We have gotten our result. Yeah, passing it here, but let's call it as explanation, right? Explanation. We only want the explanation, and here I will now pass in my prompt passer, right? I'm going to pass in the COT, so it's going to be my pass prompt, which will pass in the result. Perfect, right? So that explanation is gotten, and then I can return. So let's go with st.expander. I'll call that debugger, and then I'll just return the explanation. So what I want to return is the explanation, the entire explanation on passed, right? So this started being prompted. I'm just passing it here, and then this one here. Now this is a different format. I only want part of it, not all of this, right? So what I'll do is that I will change this one from explanation, and then I need only the steps option, right? So let's go with .get, so that in case it's not there, it's not going to crash. Right, so this steps here is coming from here, right? So we want to only just get the steps. No, you only want to get the description, or not the description. You want to get this, the final answer, if there is one. So this will be here, and that is what we are going to stream, and then we are going to have the full information there. But it would be nice if we also have the other test. So let's go with my st.write stream. Then I want to create something called stream dictionaries, right? And then I'm going to pass in my context there. So let's create this function called stream dictionary. So it's going to be the same thing, similar to this our function. It's going to be the same. How same? So stream dictionary. So we have the same idea with the streaming is going to be the same, right? Nothing much is going to change. We will have some dictionary, and then we're going to loop through the dictionary, right? So we just say for dict item in my dict list, then we just use yield. Surprise, what's wrong with the function? Yeah, I see why. So we want to yield, because we are creating a generator, the dict item, and then we just need a time.sleep, then delay, right? The same thing above is what we are doing here. And we're passing that function here just to stream it, right? So let's go back. So we run, and now you see that because we store the information, it's looking better, right? Because we stored it and we are returning it, it's looking better. But we don't want the user to see all of this. We only want to see the final answer, right? So how do we do that? Let's say how important so is AI infrastructure for LLM and business, right? So this, we are querying the LLM model. Let's pick some personality traits. This is thinking, and then this is yeah. Let's send it. Now it's thinking. So now we got the response here, the document, what it was retrieved, and then we see the debugger, right? So this is the debugger information. And it's funny, it did not get, it was able to return a response, but because of our parser, we did not get any response, right? It's funny how it worked. But we were able to get this part of the document that we uploaded where it is similar, perfect. And then we got our debugger, right, information. So this is our debugger information. And then you could see that it said, first I'll start by analyzing the query and its relevance to the context, and it did that test. Then the second, and the third, and then here is the final answer, right? So it could not, I think it could not pass this. It's funny, it could not pass the last one because of the function, but you see the point. So we have seen how to build this wonderful application from scratch, in which you have a prompt. You have seen how to build a simple application like this. We have a user, he passes in some text to a Gen AI, gets a response. Then we have seen how to build a simple RAG app using Scikit-learn and then RAG AI together with Ell and then Streamlit. So the user passes some text, it passes through an embedding layer which is exposed to some document. We get the similar test, and you could see the similar test here, which is very useful to explain. Then we also add chain of thought prompting by using think step by step to help us explain what the model was doing, which is our simple debugger here, right? Perfect. And we got our response back. So that's something that I want to share with you. I hope you have learned something. So thank you for watching this tutorial. In another tutorial, we will try and see how to build this workflow in which you have some prompt that returns some query language, which is very useful. And then we pass the query language, the SQL, the pandas function to a tools layer, and it executes against a real database and returns some response. So thank you for watching this tutorial. I hope you have learned something. So let's recap on the code that we wrote. Perfect. So first of all, we just imported all the various packages that we need. Then we imported these two to help us with our vectorization, and then L to help us with calling our large language models. And then we initialize our model. Because we are using Croc, we need to register. In case you are using OpenAI, you don't need to register it, just go straight away. Then we created some utility functions to help us create generator to help stream our text as text in a dictionary. Then we had our simple RAG function, that just queries something. And then we created our RAG plus debugger function using L, which takes in the context, the query, some personality traits, and then it returns some structured output. And then we had some utility function to pass them. This we can simplify in case we are using a better model. And then we created a vector store using Scikit-learn, and we created some simple utility functions, created our about page and our main app. So here we just load the personalities or the roles. We can change it to roles in case you want. We have a function and a session to upload some data. Based on the data, we specify what to do with the data and how to open it and how to convert it into our embeddings inside our vector store. And then we had a session to show the history of our chat. And then we use Streamlit chat elements to get the chat input. We process our text through our debugger and our parser. Then we return some result. So thank you for watching. See you another time. Adios. Paka paka. Tschüss.